We've talked about animal evolution. We've talked about plant evolution during the Paleozoic. Now we're going to talk about the death, the extinctions of some of those plants and animals. For most of the Paleozoic, the Earth was very densely populated. There was rich diversity. There wasn't a lot of biotic crises. However, there were 3 times when the planet became less hospitable, and these were times of mass extinctions. Mass extinctions are defined as a time with over 75% of organisms are lost. Right. So the very first extinction we're going to talk about is the one that happened between the Ordovician and the Silurian. Checking back at our timeline, that is after jawless fish evolved, wingless insects evolved, but before fishes really took off, before the first amphibians. Right, so during the late Ordovician, we've already talked about this extinction last time. We think this was one that was caused by the global cooling associated with the growth of ice caps on Gondwana. Gondwana was on the South Pole. Ice accumulated on Gondwana. Because of the lower temperatures, this lowered epicontinental seas, draining a lot of these shallow water environments that animals lived in and proliferated in, causing mass extinctions. Okay. Now, the next mass extinction we're going to talk about happened during the late Devonian. Looking at our timeline, this was after the first amphibians, but before they became really abundant. Okay. During the late Devonian, once again, glaciers spread over a significant portion of Gondwana. And there's evidence that there was a weakening of the greenhouse effect. So it got really, really cold during this time. And we think this was because of the evolution of forests, right? As plants were evolving, they started off really small, not very dense. Over time, they evolved into these woody, dense forests that were taking down a lot of carbon dioxide out of the atmosphere. Carbon dioxide is a greenhouse gas that caused the entire planet to cool. So because trees evolved, there was the mass extinction that took out a lot of organisms, including a lot of trilobites. All right, next, we are going to move all the way to the end of the Paleozoic, looking at the final mass extinction, which is after the mammal-like reptiles had evolved. Not mammals yet, just mammal-like reptiles. At this time, we get the final mass extinction of the Paleozoic. Happened about 252 million years ago. It's actually what we use to define the end of the Paleozoic. And there was this huge loss of biological diversity. By some estimates, more than 80% of all existing marine species and 20% of all animal families on land disappeared or were severely reduced, right? So there was another huge extinction. Now, I told you this was the event that we use as the boundary between the Paleozoic and Mesozoic, the boundary between ancient life and middle life, the boundary between pre-dinosaurs and then dinosaurs. Because of this extinction, because so many animal families went extinct, this allowed open niches, open environments for the dinosaurs to evolve into and take over. Right. Now, we don't think that the late Permian extinctions were related to any single catastrophic event. Instead, we think it was a very slow progression of a lot of things all combined together. There's a lot of evidence that there might have been extreme global warming, which caused ocean temperatures to increase. This shut down oceanic circulation. You can think of the ocean like a huge conveyor belt where water is continually flowing around in a defined pathway. And when ocean temperatures warmed, it slowed down this conveyor belt and essentially shut it down, making it so that the oxygen-rich waters at the surface of the ocean were never brought down to replenish the lack of oxygen at the bottom of the ocean, creating an anoxic environment, a lack of oxygen in the ocean, creating a mass extinction. Now, this might sound familiar to you, right? Global warming, causing ocean temperatures to increase, slowing down ocean circulation. We see this happening once again today, not near at the same scale yet, right? We're nowhere near the same scale yet, but some of the same causes and effects, some of those same dominoes were tipping over, creating the end Permian mass extinction that we are starting to tip over again today.